intensity down, the lumps show up less often.
Yeah.
Right?
But it still produces the wave pattern.
But it produces the wave pattern. It's the wave pattern you destroy when you turn on your detector.
That's what I mean, yeah.
Yeah.
Right.
But they still show up in lumps.
Right. Then it shows up as the simple N1 plus N2
That's right.
lump pattern.
That's right. Oh, yeah. Yes.
Okay.
Yes, that's right. So he says...
Sorry, we've been...
we're still talking past each other on this. Yeah. So he says Heisenberg noticed, when he discovered the laws of quantum mechanics, that the new laws of nature that he had discovered could only be consistent if there were some basic limitation to our experimental abilities that had not been previously recognized. In other words, you cannot experimentally be as delicate as you wish. Heisenberg proposed his uncertainty principle, which, stated in terms of our own experiment, is the following. He stated it in another way, but they are exactly equivalent, and you can get from one to the other. So the statement is, it is impossible to design any apparatus whatsoever to determine through which hole the electron passes that will not at the same time disturb the electron enough to destroy the interference pattern. No one has found a way around this, and I'm sure you are itching with inventions of methods of detecting which hole the electron went through. But if each one of them is analyzed carefully, you will find out that there is something the matter with it. You may think you could do it without disturbing the electron, but it turns out there is always something the matter, and you can always account for the difference in the patterns by the disturbance of the instruments used to determine through which hole the electron comes. Mm-hmm. This is a basic characteristic of nature and tells us something about everything. If a new particle is found tomorrow, the kaon, actually the kaon has already been found, but to give it a name, let us call it that, and I use kaons to interact with electrons to determine which hole the electron is going through. I already know ahead of time enough about the behavior of a new particle to say that it cannot be of such a type that I could tell through which hole the electron would go without at the same time producing a disturbance on the electron and thus changing the pattern from interference to no interference. The uncertainty principle can therefore be used as a general principle to guess ahead at many of the characteristics of unknown objects. They are limited in their likely character. That's another, I just found this interesting also when I was reading through here, is that the detector is interfering with the electron, and that results in no interference.
Yeah.
It's a confusing thing. You remove the interference pattern by interfering.
Yeah.
So he says, let us return to our proposition A. Electrons must go either through one hole or the other. Is this true or not? Physicists have a way of avoiding the pitfalls which exist. They make their rules of thinking as follows. If you have an apparatus which is capable of telling which hole the electron goes through, and you can have such an apparatus, then you can say that it either goes through one hole or the other. It does. It is always going through one hole or the other when you look. But when you have no apparatus to determine through which hole the thing goes, then you cannot say that it either goes through one hole or the other. I mean, you can always say it, provided you stop thinking immediately and make no deductions from it. But physicists prefer not to say it, rather than to stop thinking. To conclude that it goes either through one hole or the other when you are not looking is to produce an error in prediction. That is the logical tightrope on which we have to walk if we wish to interpret nature. So I think he's just trying to stress that we're going back now to how we think of things working. And he's saying that in this case, you want to predict that it's going through either that hole or this one because it is showing up in discrete lumps. And what he's saying is that
because it's coming out of the gun in discrete lumps.
Yeah, I mean it's also arriving on the detector, at the other end of the hole in discrete lumps.
Okay.
So he's basically saying you want to say that it goes through one hole or the other, and he's saying if you build an apparatus to look, then you can say that because that's what's happening. But if you don't, physicists have had to learn to not say that.
Yeah.
In other words, to take that expectation out of their biases.
Right.
And that's hard because there's not really a good explanation of how this is working.
Mm-hmm.
Okay. This proposition that I am talking about is general. It is not just for two holes, but it is a general proposition which can be stated this way. The probability of any event in an ideal experiment, that is just an experiment in which everything is specified as well as it can be, is the square of something, which in this case I have called A, the probability amplitude. When an event can occur in several alternative ways, the probability amplitude, this A number, is the sum of the A's for each of the various alternatives. If an experiment is performed which is capable of determining which alternative is taken, the probability of the event is changed. It is then the sum of the probabilities for each alternative. That is, you lose the interference. The question now is, how does it really work? What machinery is actually producing this thing? Nobody knows any machinery. Nobody can give you a deeper explanation of this phenomenon that I have given. That is, a description of it. They can give you a wider explanation in the sense that they can do more examples to show how it is impossible to tell which hole the electron goes through and not at the same time destroy the interference pattern. They can give a wider class of experiments than just the two-slit interference experiment, but that is just repeating the same thing to drive it in. It is not any deeper, it is only wider. The mathematics can be made more precise. You can mention that they are complex numbers instead of real numbers, and a couple of other minor points which have nothing to do with the main idea. But the deep mystery is what I have described, and no one can go any deeper today. What we have calculated so far is the probability of arrival of an electron. The question is whether there is any way to determine where an individual electron actually arrives. Of course, we are not averse to using the theory of probability, that is, calculating odds, when a situation is very complicated. We throw up dice into the air, and with the various resistances and atoms and all of the complicated business, we are perfectly willing to allow that we do not know enough details to make a definite prediction. So we calculate the odds that the thing will come this way or that way. But here what we are proposing, is it not, is that there is probability all the way back, that in the fundamental laws of physics, there are odds. Suppose that I have an experiment so set up that with the light out, I get the interference situation. Then I say that even with the light on, I cannot predict through which hole the electron will go. I only know that each time I look, it will be one hole or the other. There is no way to predict ahead of time which hole it will be. The future, in other words, is unpredictable. It is impossible to predict in any way, from any information ahead of time, through which hole the thing will go or which hole it will be seen behind. That means that physics has, in a way, given up, if the original purpose was, and everybody thought it was, to know enough so that given the circumstances, we can predict what will happen next. Here are the circumstances. Electron source, strong light source, tungsten plate with two holes. Tell me, behind which hole shall I see the electron? One theory is that the reason you cannot tell through which hole you are going to see the electron is that it is determined by some very complicated things back at the source. It has internal wheels, internal gears, and so forth to determine which hole it goes through. It is a 50-50 probability because, like dice, it is set at random. Physics is incomplete, and if we get a complete enough physics, then we shall be able to predict through which hole it goes. This is called the hidden variable theory. That theory cannot be true. It is not due to a lack of detailed knowledge that we cannot make a prediction. So yeah, that's interesting. Here I think he's actually he's focusing on a different part of the same experiment. Now we've moved on from look how weird it is that it appears to both be discrete lumps and also like a wave. And now he's saying even when you're checking with your light that destroys the interference pattern, you still don't know which hole it's going to go through. You have to look.
Right.
There's no way to know which hole it's going to pass through beforehand.
Yeah.
The hidden variable theory is that, well, there's something complicated happening at the source. And if we knew all those complicated things happening at the source, then we could tell you, which hole it was going to go through. And he's saying that at least in his opinion, isn't the case. That the odds, the 50-50 odds, are built into the way the stuff works.
Right.
So when I was reading that, I just started thinking of like, this is like, could there be something philosophically interesting here about odds, and gambling, like how this can really grab onto people. It's actually a fundamental thing of the universe. The universe does it all the time, rolling the dice, right? And this is why, the famous and maybe a quote that didn't happen, the thing that Einstein was supposed to have said, God doesn't play dice with the universe. He doesn't like this idea that all the way down at the fundamental level, you're still rolling some dice.
Huh. Yeah, that's interesting. I think he's also, like, basically what I got from it is that he's also pointing out that it's, to me, I just see it in that way I've already described, which is the idea of because we have to use physics. We have to use what the universe built out of this system in order to look at it.
Yeah. Yeah.
So it just interrupts it. So the thing is that is inescapable.
Right.
You can't. It's like this has become a principle that when you use any type of sensor to sense anything, it changes its initial state.
Yeah.
And so therefore you can't know what the initial state was.
Right.
That's kind of the way I think of it. But yeah,
you can only know an initial state by inference from, you can say, well, I have all this detailed knowledge about what my sensor is going to do to it. So if I use my sensor to measure what it's doing at the time that my sensor hits it, then I can maybe work backwards from there to infer its initial state.
Yeah.
Right. But you don't know. Right.
Yeah, you can't ever really know.
Right.
That's the uncertainty.
And I think Feynman's just pointing out that, like, even with the sensor, this two-slit thing is actually showing you that you can't predict which hole it's going to pass through because there's uncertainty.
Right. Yeah, it's cool. And maddening in a way. It's like it's the universe is always giving us these things that are just bothering people just like
yeah, it's like laughing. It's like wait till they get all the way down there and find out. You can't find out.
The universe has been, sending disgruntled people into their basements to do fucking research since the beginning of time.
That's right.
It's just, God, why is it doing this? It's great.
Yeah. But this is really key. He says it is not due to a lack of detailed knowledge that we cannot make a prediction.
Yeah.
This is the whole thing with the uncertainty principle. And I think that, doesn't Sean Carroll constantly reference this, the whole collapse of the wave? He basically is saying this is Heisenberg's thing. And, that all stuff follows this these basic equations. Okay, so Feynman says, I said that if I did not turn on the light, I should get the interference pattern. If I have a circumstance in which I get the interference pattern, then it is impossible to analyze it in terms of saying it goes through hole 1 or hole 2, because that interference curve is so simple, mathematically, a completely different thing from the contribution of the two other curves as probabilities. If it had been possible for us to determine through which hole the electron was going to go if we had the light on, then whether we had the light on or off is nothing to do with it. Whatever gears there are at the source, which we observed, and which permitted us to tell whether the thing was going to go through 1 or 2, we could have observed with the light off, and therefore we could have told with the light off through which hole each electron was going to go.
That's right.
But if we do this, the resulting curve would have to be represented as the sum of those that go through hole 1 and those that go through hole 2, and it is not. It must then be impossible to have any information ahead of time about which hole the electron is going to go through, whether the light is on or off, in any circumstance when the experiment is set up, so that it can produce the interference with the light off. It is not our ignorance of the internal gears, of the internal complications, that makes nature appear to have probability in it. It seems to be somehow intrinsic. Someone has said it this way: nature herself